Alright, let's find the coordinates of the possible inflection points. So to do this, first we take the second derivative of this function. So let's take the first derivative first. So f prime of x will be equal to x squared minus 4x plus 1. Right, let's find the second derivative of this function. So f double prime of x is equal to 2x minus 4. Right? And then we set the second derivative to 0. And then solve for x. So we get x is equal to 4 over 2. So which is 2. So 2 is the x value of our possible inflection points. To find the y value, we plug 2 back into the function. So f of 2 is 2 cubed. Oh, my bad. Yes, 2 cubed over 3 minus 2 times 2 squared plus 3. So we get 8 over 3 minus 8 plus 5 plus 3. Actually, yeah, plus 5. Which is negative 1 over 3. Okay. So our possible inflection point is 2 and negative 1 over 3. So that's A. And then we try for B. We need to find the open intervals where the function is concaving up or down. So to do that, we need to, let's plot our inflection points first and see. So let's say here is the x-axis of our function. Okay, so our inflection points happens at about x equal to 2. So we need to find if the sign value of the left side and the right side. So let's pick a point in the left and pick a point from the right. So from the left, let's pick x equal to 0. From the right, let's pick is x equal to 3. It's best to pick integer numbers, so it's easier to calculate. So now let's plug 0 back into the function. So f of 0, f back into the second derivative of the function to find if it's concaving up or down. So f of 0 would be equal to 2 times 0 minus 4. Oops. It's equal to 2 times 0 over 4 minus 4. So we get negative 4. So we know that the left side of x equal to 2 is negative. Now let's find the right side of the inflection point. We plug in 3 into the second derivative of the function. We get 2 times 3 minus 4. So we got 6 minus 4, so we get 2, which is positive, right? So what does it mean? It means that from the left side of the inflection point, the sign is negative, but from the right side of the inflection point, the sign is positive. That means this is a legitimate inflection point. It is not a fake inflection point. And we know what? We know that from all the way from negative infinity to 2, it is concaving downwards. Okay? It's concaving downwards. And then starting at 2, the function concaves upwards again because the sign is positive. So it might look something like this, but we're not completely sure. Let's write the interval notation for this. So it concave down, the function concave downwards from negative infinity to positive 2. And then from there on, it concave upward. From 2 to positive infinity. And yes, the positive inflection points we found, 2 and negative 1/3, is an actual inflection point.